Hey guys, this is Unit 6. We're on day 5, and we're going to do the rhombus today and talk about its properties. But in the warm-up, we have a parallelogram. That's important to know so we can use the properties of our parallelogram that we know. We also have bisectors of angle ABC and DCB meet at E. Okay. And we have a point on AD. And it says that angle A is 68 degrees. So angle A is 68. They want you to determine and state the measure of angle BEC. So B to E to C is this angle here. All right, now we got to talk about our properties of a parallelogram and angles. We know that in a parallelogram, opposite angles are congruent, which means that this entire angle at C, so those two angles that you see there and there, they have to add up to equal 68 degrees so that the opposite angles in the parallelogram are equal. And I'm pretty sure that they told us that we have an angle bisector of angle ABC and angle DCB. DCB is this one that we're talking about right up here. So this part is equal to this part. And so if we take 68 degrees and we divide it by 2, we're going to get 34 degrees for each one of these angles. So 34 here and 34 here. Okay. Let's talk about consecutive angles in a parallelogram. Any two consecutive angles like A and D have to add up to equal 180 degrees. So let's see if that would help us. So if this one's 68, 180 degrees, take away 68 is going to leave us with 112. So this angle will be 112. All right, and opposite angles are equal in a parallelogram, so this entire angle at B is also 112. And remember up here how they said they had a bisector of angle ABC? That means that these two angles that you see up here that add up to 112 are equal because that angle is being bisected or cut in half. So we're going to cut 112 in half. And when we do, we end up with 56. So this angle here is 56, and this angle here is 56. And now we're almost finished because the angle that we have to find is the last angle in this triangle that I just highlighted. In that triangle, we have an angle of 56 and an angle of 34, and then our question mark. So in a triangle, we have 180 degrees. And we're going to take away that 56, and we're going to take away the 34, and we will be left with 90 degrees. And so that is our question mark, and that's our answer. That's the measure of angle BEC. All right, so that one's finished. All right, let's go down to properties of a rhombus. So remember, a rhombus is a quad. A rhombus is a trapezoid. And the reason why it's a trapezoid is a trapezoid needs at least one pair of parallel, and it has it. Okay? A rhombus is a parallelogram because a rhombus not only has one pair of parallel, it has two pairs of parallel. Okay? And we're going to go ahead and say that our rhombus is a parallelogram with one added bonus property that it has consecutive sides congruent. It actually has all consecutive sides congruent, or all sides congruent, but they usually say that it's a parallelogram with two consecutive sides congruent. Okay, so what that means is that this side here needs to be equal to this side here. Those are consecutive sides, or it could have gone the other way. But because it's also a parallelogram, we know opposite sides are equal, and so that also gets then tick marked. And then this also gets tick marked to be opposite sides here congruent and opposite sides there congruent, and then they end up all being congruent. So all sides are congruent. All right, not just opposite ones, not just consecutive, all sides end up being equal. Okay, it has the 5 properties of a parallelogram. And we already talked about the sides being parallel and sides being equal. But don't forget, just like in the warm-up, that opposite angles are equal, and opposite angles here are equal. And also don't forget that consecutive angles here would equal 180 degrees. And here would equal 180 degrees. And here would equal 180 degrees. And one more. These consecutive angles here would also equal 180 degrees, just like it does in the parallelogram, because a rhombus is a parallelogram. All right, and we have one last thing to talk about. We talked about the sides, we talked about the angles, so now we have to talk about the diagonals. Okay, when I draw the diagonals in, rhombus is what I call a slanted shape, so the diagonals are not equal. However, the diagonals are perpendicular to each other, meaning that right here is a right angle. So here would be a right angle, so here would be a right angle, and so here would be a right angle. The diagonals are perpendicular to each other. This is the first shape that happens in. Okay? The diagonals still bisect each other. Okay? So this piece of the diagonal would be equal to this one because this right here is still a midpoint, because remember that happens in a parallelogram, and a rhombus is a parallelogram. This part of the diagonal would equal this part of the diagonal. Okay? And one last thing that those diagonals do is that they bisect the opposite angles. So diagonals bisect opposite angles. Kind of like what happened in the warm-up, but it happens at all four angles. Okay, so for instance, let's pick a number so we can see that what actually happens. So for instance, let's say that this angle is 60 degrees. Well, then this is 30, and this is 30. And it's going to happen here too, 30 and 30. Okay? What's cool is that the 90s in the middle make all four of these triangles that we see. I'll highlight one so you can see it a little bit better. But that triangle has two angles that we know inside of it already. For instance, the 90 in the middle and the 30. So you could do triangle sum and come up with that this angle equals 60. All right, which means that this angle would be 60 since the diagonals bisect the angles. Okay. Also, that makes sense because two 60s would make this 120, and then that would make the consecutive angles add up to equal 180. Okay. And if those two are 60, then these two are 60 up here too. So by knowing one angle inside of a rhombus, we can fill the rest in, kind of like when we did our rectangle. All right. So all those properties are happening. So a rhombus actually has three more properties than the parallelogram. Okay, these three we have to focus on when we do the rhombus. All right, all sides equal. Diagonals are perpendicular, so right angles in the middle, and then the diagonals split those angles in the rhombus in half. They bisect them. Okay, so now we're going to answer some questions based on what we know about the rhombus. In number 1, it says that the lengths of the diagonals of a rhombus are 10 and 24. So I'm going to go ahead and draw a rhombus. I try to draw it like a parallelogram, but I draw it so that all the sides look equal. Okay, and then they're talking about the diagonals, so we'll draw the diagonals in. And they're giving me the lengths of the diagonals. Okay, so the longer diagonal is 24, the shorter one is 10. What I'm going to do instead of labeling 10 and 24 is I'm going to cut those in half, okay, because it'll be a little bit easier to label in our picture, and it'll be a little bit easier to use. All right, so the 24 is going to get chopped in half and get 12 and 12, so that whole diagonal is still 24, and the shorter diagonal is going to get chopped into 5 and 5, okay? They want us to find the length of one side of the rhombus. So it doesn't matter which side we find since all sides are equal. So I'm just going to put my question mark on this side, but it could go on any of the sides. All right, so the one thing we have to remember to do in order to do this problem is to remember that these are 90-degree angles in the middle. Okay? So that if I look at just maybe this triangle here, can you tell that it's a right triangle? It has a leg of 5, a leg of 12, and an unknown hypotenuse. Well, we have something in our toolbox that works on the sides of a right triangle. Okay? And what works on the sides of a right triangle is the Pythagorean theorem. Okay, so I'm going to take that yellow triangle and I'm going to pull it out of here and put it at the right angle there. I'm going to go ahead and put this side being the 12 and this side being the 5, so you guys can see that I literally took this triangle out of here and straightened him out, okay? And then this is still our question mark side. All right, and now I'm going to go ahead and say a squared plus b squared equals c squared. I'm solving for the hypotenuse, so the 5 and the 12 make the a and the b. And 5 squared is 25, 12 squared is 144. Add them together, you get 169. And then to get rid of the square, we square root, and the square cancel each other out, leaving us with c equals. And if we type in the square root of 169 in our calculator, it actually comes out perfect. It's a nice number of 13. And therefore, this question mark is now 13. And when we put it back in, you're going to see that that is a side of the rhombus and that all sides of the rhombus are 13. Okay? And so we can go ahead and say that a side equals 13. And this part's done. Okay? In part B, they asked us to find the perimeter of the rhombus, which is just adding up the 4 sides of the rhombus. And since all 4 sides are equal and they equal 13, I'll be adding up 13 4 times. Or you could do 13 times 4 as a shortcut, and it ends up being 52 for our perimeter, okay, which is the distance around the shape. Okay. All right, in number 2, it says that the accompanying diagram of rhombus ABCD, it tells us that the measure of angle ABD, A to B to D, this angle here is 50. And they want us to figure out the measure of angle A. All right, so if you remember from up above, the diagonal cuts this angle B in half. So if half of it's 50, the other half has to be 50. Okay, and then we can talk about consecutive angles. Consecutive angles have to add up to equal 180 degrees. And so if we look at this whole angle and it's 100, then there's only 80 left for angle A. And so we can say that angle A equals 80 degrees. Okay. So hopefully that's helpful. All right. The other way you guys can have looked at that question, and I'll just show you one more way. Let me erase what I have here. Okay. I'm going to go back and reset and put the 50 back in my question mark back. Okay. Remember that in a rhombus, all sides are equal. So if you just take a look at this triangle here, notice he has 2 equal sides. Therefore, he's going to have 2 equal angles across from him. That one and that one. And so if this one was 50, like they told us, this one would be 50. Okay. And then we could do triangle sum and say 180 degrees in that yellow triangle. Take away the 2 50s, would also leave you with 80 degrees for the last angle. So just another different way of getting the same exact answer. Okay. Good. All right, let's take a look at the third one. Number 3, it says in the diagram below, PQRS is a rhombus with diagonals PR and SQ, and they tell us that the measure of angle 1 is 33 degrees. They want us to find all the other angles, all right? So the first thing I'm going to do is, because this is a rhombus, I'm going to get 4 of the angles out of the way by putting the 90s in the middle, okay? And then remember that the diagonals bisect the angles in a rhombus. So not only is that 33, but this would be 33. This would be 33, and this would be 33. Okay, because remember, opposite angles have to be equal. And then if you take a look, we can do and talk about the consecutive ones. Remember that this whole angle is 66, okay, and that these consecutive ones have to add up to equal 180. Therefore, this whole angle here has to be, 114. And if we split 114 equally, okay, we end up with 57 and 57. And therefore, these two are 57s. Okay, or you could have also done this. You could have looked in this triangle and said, hey, in that triangle is 180 degrees. If I knew the middle one was 90 and the 33, we could take them away and have been left with the 57 that way as well. So just a different way of getting it. But there you go. All the angles are filled in. All right. In number 4, it says we have a rhombus ABCD with diagonals AC and DB, and they tell us that AD is 10. Okay, and that's already put in there for us. If the length of diagonal AC is 12, all right, so the whole diagonal at AC is 12. So what I'm going to do is I'm going to split it 6 and 6. They want to know the length of diagonal DB, all right? So remember in a rhombus, I'm going to fill these 90-degree angles in. And I'm going to take this triangle. In fact, I could have taken any triangle, to be honest with you, since all sides of the rhombus are 10, not just that side. And I'm going to pull that triangle out of there, kind of like I did in question number 1. Okay? And I'm going to kind of straighten them out when I pull them out of there. All right, and there's the 90-degree angle. That's right here. Okay? Across from the 90-degree angle is that 10. So across from my 90-degree angle is my 10. Okay? And then if you turn them and put them back in that picture, you're going to see that this is 6 from our picture that's here. Okay? And that this is the part that we don't know. Okay? And that's not going to be dB, but that's going to be half a dB, just like we took the 12 and split it into 6 and 6. And so the thing that works on the sides of a right triangle is our Pythagorean theorem again. This time we just have to watch out, though, that 10 is our hypotenuse, so 10 has to go in for C. Okay? And 6 could either go in for A or B. I put it in for A. And then I'm going to square them, because according to PEMDAS, exponents come first. Okay? And now I'm going to take away 36. And I'm going to have B squared equals 64. And then I'm going to take the square root, because the square root and the square cancel each other out, leaving me with B equals, and the square root of 64 is perfect. It equals 8. Okay? And now what I'm going to do is I'm going to go back and say that this is now 8. And when I take that triangle and I put it back into my picture, you're going to realize that that's 8. And in a rhombus, if half the diagonal equals 8, the other half equals 8. And now I can tell you that DB, part plus part, 8 plus 8, has a length of 16. And that one's finished. Okay, on the back side is proofs, and we're cutting those out. And so our day of notes is finished. All right, I will see you guys on the next day of notes for our last shape of the square. All right, bye guys.